So yeah, let's get started. Yeah, hello everyone. Yeah, thank you very much for coming to the Luohan Webinar. Today we are very happy to have the Professor Anton Korinek. Anton Korinek is a professor in the Department of Economics and at the Darden School of Business at the University of Virginia, as well as a David Rubenstein Fellow at the Brookings Institution. His current research and teaching analyze the implications of AI for business, for the economy, and the future of society. He's also research associate at the MBR, at the CEPR, and at Oxford Center for the Governance of AI. And he's an editor of the Oxford Handbook of AI Governance. In his book on artificial intelligence, he analyzes how to align the development of AI with society's values. His research has been published in top journals, including the American Economic Review, the Review of Economic Studies, and the Journal of Public Economics. It has also been cited on Bloomberg, in The Economist, and in the Wall Street Journal. He has won several fellowships and awards, including from the Institute for the New Economic Thinking, the Effective Altruism Long-Term Future Fund, and the Hewitt Foundation. Today, he's going to talk about his paper, The Preparing for the Non-Existence Future of Work. Professor Korinek, the floor is yours, and you have 90 minutes. Yeah.
Thank you very much for the kind introduction, Sang-Woo. So this is joint work with a sociologist, actually, Megan Julefs. And let me start with a brief motivation. So we have seen that there have been growing concerns that new technologies, and in particular, artificial intelligence, may substitute for human labor, and there are fears of technological unemployment and so on. At the same time, this comes after we have seen decades of stagnating wages for lesser skilled workers in advanced economies, and that has led to growing political discontent in a lot of advanced economies. And at the same time, there are also predictions that there are really impending transformative advances in AI, so that AI may soon reach levels of capability that are much, much more human-like, and that really adds new fuel to the question. So the objective in this paper is that we try to wrap our heads around how to think about an economy in which AI will increasingly be able to do any kind of work that humans are able to do. And the premise behind this perspective is that the human brain is, from the perspective of information theory, a computing device. It takes inputs through our senses, our eyes, our ears, our other three senses, and it produces outputs. It produces everything I'm saying right now is produced by my brain. All the experiences that you are having as you are listening are also produced by your brain. So the perspective of information theory really puts the brain as a computing device kind of at the center of all of this. Now, of course, we know it's not only brains that are computing devices, but we also have the kinds of computers on which we are all currently watching this webinar. And computers are input-output devices. In their most intelligent form, so are AI systems. So many researchers predict that artificial intelligence may eventually surpass human intelligence and may still continue to advance. And that implies if artificial intelligence can do everything that our human brains can do, if we add the necessary robotic devices to it, there is really no task that would be reserved only to humans from that perspective. So if we really experience these kinds of transformative advances in AI, that may pose quite severe challenges for humanity. Some people talk of an AI control problem, But what I want to emphasize in today's talk is that the potential economic harms from displacing labor are really a major category of the risks emanating from transformative AI. And that's what motivated us. So the main questions that the paper will tackle in this spirit are the following. First, we know that there has been a long history of fallacies about technological progress. People predicted since the beginning of the Industrial Revolution in the UK that human labor will be redundant, but they have been wrong for the past 250 years, right? So am I committing the same mistake here? Or how should we make sense of the current predictions about labor becoming redundant? And then if these predictions start becoming true, should labor be phased out if we approach such a world? How should we phase out labor? And then perhaps most fundamentally, how should we set up institutions for a future in which work may be non-existent if we want humanity to still experience welfare? If we want humans to benefit from it, as opposed to falling into all kinds of potential dystopian outcomes that may happen if we just let the displacement of labor take place without any accompanying public policy measures. So what are our three main contributions? The first one is that I will develop an economically rigorous taxonomy of the concerns about the non-existent future of work. So to make sure that we are not just repeating what the Luddists already were afraid of 250 years ago, I will develop a careful taxonomy. I will emphasize that the first concern that we are already experiencing to some extent in advanced economies is labor saving progress. The second concern is the technological substitutability of labor. And the third concern, the economic redundancy of labor. Then I will analyze optimal policy in the face of declining wages or declining marginal products of labor. And finally, I will relate this to the design of real-world institutions that would counteract the potential risks that we may see if labor really becomes redundant. So let me pause for a moment before I jump into the main material and ask if anybody has any questions. Okay, so then I will carry on. And I will start with my taxonomy of these three main concerns, and then I will move on to topics 2 and 3. And feel free to raise your hand at any time if you have questions, or feel free to also just speak and ask as if we were sitting in a physical room. So let me start with the taxonomy of concerns about the end of labor and how we should account for that in economic models in a rigorous way. So first, I want to emphasize again that for the past 250 years, since the Industrial Revolution, technological progress as a whole has really benefited labor. It has been what Hicks called neutral, roughly speaking, meaning that all factors of production have benefited roughly equally from advances in technology. And that means that living standards of workers have risen in tandem with economic growth. However, there is no economic law that progress must be neutral. Some people think that, oh, we know that progress always helps everybody, but that's not true. It depends on how technological progress or technological change affects the marginal products of labor from an economic perspective. And then there's, of course, also an institutional perspective. It depends on how our institutions evolve. So the first concern is that technological progress may reduce the demand for labor at given market prices, or if we put that in terms of the production function, it may reduce the marginal product of labor, even as it increases the total amount of resources that can be produced with a certain amount of factor inputs. So we can produce more, but labor may be less necessary. That's what would be captured by this decline in the marginal product of labor. There are already some harbingers of that. For example, in recent decades, we have seen in the data that progress has been biased against some kinds of labor, in particular against unskilled workers. And as a result of that, the wages of unskilled workers in the US and other advanced economies have been more or less stagnating for the past 4 decades and have been really lagging overall economic growth. And what we have also seen in the past 3 to 4 decades, the labor share of income as a whole has declined a little bit. There are some debates in the literature, but I think the overall impression is that the labor share of income has declined a little bit. So that means that labor has not proportionally benefited from technological progress, but has fallen behind a little bit. So let me illustrate this perhaps in the following graphs. And this is really a taxonomy that Hicks already developed in the theory of wages in 1932. So if we have Hicks neutral progress, then as output rises, as we move along the horizontal axis, our labor income W times L, wages times labor, is growing at exactly the same rate. So that means technological growth benefits the factor labor proportionately. What we have seen a little bit in the past 4 decades in advanced economies is that progress has been biased against labor. So it means labor has not quite benefited at the same rate as the other factors. The labor share of income has declined, even though the overall earnings of labor have still increased. The big concern is that progress may be truly labor saving. So that means that as output grows, the absolute income of workers, the absolute level of W times L may be declining. And that's what some categories of workers, like unskilled males in the US, have already experienced in the past 4 decades. My understanding, but many of you in the webinar know much more about it. There are some concerns that similar things are starting to happen in manufacturing intensive sectors around the world, including in countries that have really seen a huge growth spurt like China in the past few decades, that in the manufacturing sector, for example, similar tendencies are starting to kick in. So one more point I want to emphasize is we know that if there's technological progress, output overall goes up. So that means if output overall goes up, somebody needs to be earning that extra output, right? And one insight that has been used by some economists to argue against the possibility of labor-saving progress is that, well, if we live in a 2-factor world where there's only capital and labor, the marginal product of capital is something that we think of as being pinned down by our rate of time preference. Or another way of saying this is, if capital is a reproducible factor, we will always accumulate more and more and more capital. And if there's technological progress, that is biased in favor of capital and against labor, then that makes us accumulate more capital up to the point where the returns of capital are the same, and then labor necessarily needs to be better off because we have more output, we have had technological progress. So in a two-factor world, where one factor is capital and can be accumulated, it is true that labor will always be better off. But that's no longer true if we add other factors to the economy. For example, I am showing in a paper with Joe Stiglitz that if we add another fixed factor like land, then the marginal product of labor may decline, even if capital accumulation makes sure that the marginal product of capital is held constant. So there may be progress that benefits other factors than labor. It could be land, could be energy, like, for example, if compute becomes a very important factor in the economy. But there is no natural law that labor will benefit from progress. And that's really my main message here under concern one. So if this concern materializes, then something that Wassily Leontiev, one of the first Nobel laureates in economics, already predicted in 1983, that the role of humans as the most important factor of production is bound to diminish in the same way that the role of horses in agricultural production was first diminished and then eliminated by the introduction of tractors. So in summary, again, concern one is that we have progress and labor is left behind. Now, what is concern two? Concern two is that labor may become fully technologically substitutable. So one of the reasons why labor has benefited from progress in the past 250 years is that labor has always been a bottleneck in production. We have automated some tasks, but not other tasks. And as we automated some, the remaining tasks were more and more a bottleneck to economic growth. There was more scarcity, and that scarcity is what pushed up the wages. However, at some point, machines may be able to do everything. How do we capture that analytically? So analytically, assume that we have some vector of labor inputs, L, and some vector of capital or machine inputs, M. So this can be different types of capital, different types of machines, and labor can be different types of labor. So analytically, concern two says that for any given labor inputs, for any L that's greater than 0, and for given units of capital inputs, there exists a level of extra machines of delta M, such that what we can produce with the extra machines and 0 labor is greater or equal than what we could produce with the labor and just the machines that we had in the beginning. So if this condition is satisfied, then labor is fully substitutable for, and that would be when concern two has materialized. Let me first observe that this is not currently possible. At the moment, there are still lots of things that only labor can do. But we do know that advances in AI are proceeding rapidly. What I also want to point out is that concern one is neither necessary nor sufficient for concern two. So we can have labor-saving progress, and we have seen that even though labor is not fully substitutable for yet. It could also be that labor is substituted for, but that we still have neutral technological progress because it's just too expensive to substitute to labor. However, if concern two materializes and Moore's law or something similar continues to hold for a few more decades, then at some point concern one will automatically happen. So in other words, if we can substitute for all labor, if it's technologically feasible, And then Moore's law makes it cheaper and cheaper and cheaper to produce machines that can actually do that. Then eventually, concern one, that progress is biased against labor, will also materialize. So let me.
Can I ask you a question?
Please do.
Oh, can you go back one slide?
Mm-hmm.
So in the equation here, so the delta to produce more machine, the delta M, you also need to, you'd also require a certain amount of labor to produce the more machine, or no? I'm just trying to understand the logic.
Yeah, so that's the statement here in the equation. It's essentially a statement of technological possibility. It just says that production technology is such that there exists a level of machines so that we could do everything using labor.
Okay.
I think what you are referring to is about a more dynamic story of how do we get to that level. And I think you're absolutely right. So let's say in 10 years from now, there's some huge technological progress in AI, such that any human labor can be technologically substituted for. It is probably true that we still need to build that delta M. That delta M may still be quite large. And we will still use humans for a couple of years to accumulate that delta M before we can retire as humanity. Does it make sense?
Okay, yeah, that makes sense. So yeah, okay, that's interesting. Okay, yeah, I got it. Thank you.
So the concern is one of technological possibility. And in fact, in 2 slides, I will go back to that point because it's a very important one.
Okay.
Let me first just go over a few predictions about the technological substitutability of labor. So people like Ray Kurzweil or Elon Musk say that human-level AI, meaning AI systems that can do anything that the human brain can do, will already be reached in 2029. That's a fairly aggressive timeline. And for some people, it has actually shifted in just the recent years. They have become more aggressive in their timelines. Now, a broader survey of AI researchers and HEI researchers conducted by Nick Bostrom suggested that we would reach that level in the mid-2040s. Another survey conducted by Grace et al. In 2018 predicted that, well, there's a 50% probability that it may happen by the 2060s. Of course, there are also some people who predict that it will never happen, but they are by now a minority. One kind of comparison that I thought would be useful is to compare the information processing capabilities of the human brain and of supercomputers. Now, the human brain, and this is kind of difficult to estimate since we are not a digital system, but the human brain is estimated to be able to perform something on the order of 10 to the 13 to 10 to the 17 floating point operations per second. So this number here, the midpoint is 10 to the 15 flops. Now, the most powerful supercomputer that we know about, Frontier, is able to perform 2 times 10 to the 18 floating point operations per second. Now, of course, and that goes back at some level to Sang-Woo's point, that supercomputer costs $600 million. And if it costs $600 million to do my job, then I think I don't need to worry about being replaced quite yet. However, Moore's law is continuing. And that means the same number of flops will cost 300 million in 2 years, 150 million in 4 years, 75 million in 6 years, and so on and so forth, for however long Moore's law will hold. And I think right now we don't have any strong reason to believe that it will completely disappear. Most experts predict that maybe Moore's law slows down, but it's unlikely to just stop within the next decade or two. Now, as we discussed, what matters to us economists is not only what's technologically possible, but what matters in the economy is what's cost effective. And you and I, we don't need to worry about being replaced by a machine if it costs $600 million to replace us, because frankly, we are a little cheaper than $600 million on the labor market. So the third concern is that we can not only do everything that humans can do, but that we can do so more cheaply. And the question is, cheaper than what? So first, machines may be able to do it cheaper than the current level of wages. But eventually, if progress continues, they may be able to do it cheaper than the human level of subsistence cost. So that means machines would do everything we can do cheaper than what it costs for humans to stay alive. And that's the point that I call the strong economic redundancy of labor. So more formally, this concern 3 has materialized. If machines can perform any economically valuable task cheaper than the humans valued at their subsistence cost, which are labeled by C0 here, or in math, for any vector of labor and machine inputs, there are some extra machines, delta M, such that we can produce the same or more by using 0 labor and only those machines. And in addition, the machines, and I have normalized the number of the units of machines here to be denoted in dollars. So the cost of the machines to replace all the human labor is less than the subsistence cost of the labor. So that's when human labor is truly redundant, when labor has become a dominated technology, and when it's simply not cost effective to use labor, even if we pay humans only what they take to survive.
Hi, Anton.
Yes, please.
Can I ask one question regarding this task? Because I think as the economy grows, there are going to be new tasks will appear along the way, right? For those type of new tasks. So as the economy develops, there are going to be new tasks.
Yes.
Like appears. Then for those type of new tasks, it's not really about the computation speed. It's about the creation, the creativity, or the ability to process very complicated, complex things. In that case, I think for those type of new tasks, human brains will still have the comparative advantage. In the beginning, maybe later on, people learn how to automate this using the AI or other techniques. And then this task can be automated or can be replaced by the capital. So still, I think there's this tendency between the competition between the human and the machines. There are going to be new tasks come along the way. Initially, the cost will be so high to perform by a machine, and later on, it's going to be automated. So if this kind of logic goes through, I think in the long term, still you're going to see that there's going to be still a lot of demand for labor, right?
I see. So I think this is an argument that I hear from a lot of economists. So if we can invent new tasks, then we don't need to worry about demand for human labor, because humans can just be allocated to those new tasks and we let the machines do the old tasks. In some ways, I think it is what happens, for example, in the Acemoglu-Restrepo papers, which have been very influential in this debate. Now, the perspective that I am trying to suggest is that even creating the new tasks, even that kind of creativity, it's essentially computation that our brains perform. So creativity is computation. You can say tasks that require emotional intelligence are based on the computation of our brain. And so if you hold this perspective, then machines will at some point be much more creative than humans. They may also be much more able to process emotional information than humans are. And so if you have this perspective of the human brain as a computation device, then there is nothing special about creativity other than that only humans can do it right now. But that doesn't mean that more advanced machines won't be able to do it at some point. So we are making predictions about the future here, right?
Yeah.
And so that means we won't know until it happens if my prediction makes any sense. And I may very well say in 50 years from now, I hope we will both still be alive and very well at the time. I may say, well, Xiqie, from everything I have seen, I think you were right. We have always created those new tasks. But currently, my belief is that even the creative tasks, the creation of new things, is something that machines will be able to do better at some point. And let me perhaps add one more observation to that. So do you remember when DeepMind built AlphaGo and defeated the world champion Lee Sedol in AlphaGo?
Yeah.
Afterwards, Lee Sedol gave an interview, and he said something to the extent that he has never seen any human play in such a creative way, and that he felt like he was really confronted with the superhuman level of not only ability to play, but also of creativity.
Yeah, but that maybe that example is like not very good because it's old task, not a new task.
It's already 6 years old too, right?
Yeah. Okay.
Yeah, so that's a fair counter argument. But ultimately, if you look at what the brain does biologically and from an information theory perspective, it is computation. And when I come up with a new paper, the way that I explain it to myself is I put together lots and lots of things that my brain has kind of accumulated in my lifetime. I perform computation and I come out with new things. And if it's sufficiently different from everything I've seen before, then I consider it creative. Now, you know, sometimes I produce something new with my brain that I think is creative, but other people who have greater computation power say, well, that's kind of obvious. So that happens sometimes, for example, when I talk to Nobel laureates. And that tells me that perhaps what all of us humans consider creative will be considered quite obvious by machines in a few decades.
Yeah.
But yeah, I mean, ultimately, we are talking about something that doesn't exist yet. And so that means we can voice opinions, but we can't test it yet. Does it make sense? And I very much appreciate the conversation because I do agree that this is kind of one of the critical differences between the view that I'm proposing and, for example, the view articulated in Acemoglu-Restrepo, and probably the mainstream view in economics. So one more observation. Concern 3 is a sufficient condition for concerns 1 and 2 to materialize. And one interpretation of that is that that would mean that we would expect it to happen later than concerns 1 and 2, so that it would be further in the future. Now, what I also want to emphasize, concern 3 is quite strong, and we can actually weaken it and still call it as labor being redundant. So even if there are some jobs that remain for humans, but there's not enough of them, it may be that the marginal product of labor in a competitive market falls below human subsistence, excuse me, below human subsistence cost. So that weakened version of the economic redundancy of labor, I call it 3', is that machines push the competitive wage of human labor below the subsistence cost of humans, or in other words, for given supplies of labor and machines, the marginal product of labor is less than C0. So concern 3' is weaker than the strong redundancy of labor because it's implied by concern 3 and not the other way around. And I should also say concern 3' implies that progress is labor saving, but it can happen even if labor is not fully technologically substitutable. So let me kind of provide an example that's a little bit silly, but it makes it tangible. Imagine that we have automated everything in the world, including the writing of economics papers, but we need one worker who goes into a room in the morning and pushes a button to turn on the machines, and that needs to be a human for some reason. Then the humans are not technologically substitutable, so concern 2 would not be satisfied, but labor would be weakly redundant because there's only demand for one human, and we have 8 billion who all may want a job. So this example illustrates that we can have the weak redundancy of labor. There could be some demand for humans, but it's so low that the competitive wage level for humans is still below our subsistence cost. And in that sense, humans are economically no longer able to earn their keep. They are technologically redundant. So the next thing I will do, I will discuss a couple of the objections to redundancy. But let me first ask, does anybody have questions about the 3 concerns? Okay, let me go over the objections. In fact, Shijie has already anticipated one of them, the new jobs or new tasks that I'm listing under point 3 here. But there are more objections. So the first kind of obvious objection that anybody would tell us is, well, we have worried about that already for the past 250 years and it has never happened. So my prediction departs from historical experience. My response to that would be to say, well, the Industrial Revolution also really departed from historical experience. The fast takeoff that China has seen over the past 4 decades also departed from historical experience. So sometimes there are turning points in history, and we may be just at the cusp of another one of these turning points where the economic regularities that we saw in the past 250 years in the US or in the past 50 years in China may no longer be true going forward. A second point is, well, it's just technologically impossible. The brain can do something that's so special that machines will never be able to do it. And so humans are inherently superior. So I will say that, again, this is something, we're talking about predictions about the future. So maybe we will find out in 100 years that there's really something special the brain can do that cannot be done by any non-biological entity. But the best things that we know about neuroscience, cognitive science, information theory tell us that what the brain does is not fundamentally different from other forms of information processing. And that means what the brain does is technologically possible, and which is also able to.
Could I ask a question?
Please.
I mean, what your objections actually are much more similar to Keynes's in 1931 than others. In that he said he thought in 1931 that capital, I mean, it wasn't AI, but it was capital, was going to take over work. But of course, Keynes's big mistake is something that Gary hinted at. He completely missed the development of the service economy. For example, at his time, tourism, travel was almost nothing. Hospitality was almost nothing. Pet services were nothing. Personal traders were nothing. They were employing a tiny fraction of people. Today, those are employing most people. So if you look at the evidence, it's obviously against you. There's no way I can be convinced that we will not want to travel anymore because machines will be able to do the travel. I will want to go tourism. I live in London. I want to go in the summer to the beach in Greece. Well, I need people to take me there. I need people to serve me there when I go. How would those jobs ever be eliminated?
Well, so there. I first of all, let me say, I completely agree with the premise that we would still want to consume things and that we would want to consume services, right? So I also want to travel. I don't think, though, that necessitates that humans enable those travel experiences. It may be much safer. Some people tell me it's already safer now for a robotic car to take you to the airport, for a automatic pilot to fly you to Greece, and it may also be quite well possible within the next 2 decades to have a robotic waiter who will serve you when you're sitting on the beach in Greece and you would want to enjoy a drink. So
someone needs to repair those things, and you cannot have robots repairing other robots.
Why?
Because how are you going to do it? There will be airports where a car comes and picks me up without any driver, takes me to the airport. I get in. If the aircraft isn't taking off, another robot on its own gets a message and comes and repairs. It's so space age. Not even my grandchildren will be able to live that experience.
So I think
I don't think it. Now the other issue is that it's up to us if we want to develop that system. I mean, there are now restaurants that are partially operated. I wouldn't go to those restaurants. I don't like them. I prefer having people prepare my food because it tastes much better. A chef, a good chef is like an artist. Like I'd rather go to the Louvre and look at the Mona Lisa than sit in front of my laptop and look at some mechanical thing that is produced. And as long as I'm prepared to pay for it, it will be offered. I mean, it's up to humans to do that, to develop those machines that do those things, and the evidence is that humans don't want to move in that direction.
So let me say 3 different things. First one, I strongly agree that it's up to us humans, and it may be one of the most consequential decisions that we as a species have to make about our future. The second thing that I want to say is going back to the car and the repair of the car. I think you're absolutely right. All evidence suggests that we will be able to automate the driving of the car before we can automate the repair, because it's a much more regularized task. The third thing I want to say, though, is that I think we are kind of so used to the perspective, I want to call it the anthropocentric perspective, that only our human brains can do certain things. And it has always been true in the past. So you are absolutely right describing the past and probably the very near future. But what would be required, for example, for a robot to repair a car or for a robot to repair another robot is that it has a very comprehensive model of how this thing works, like an abstract model, not just programming that tells it like an assembly line robot to move this thing from here to there and weld it on and then do the same thing again and again and again and again. So it needs an abstract model of the world in a similar way to the abstract models that we have developed in our brains and that take us decades to develop if we want to be good engineers or good economists or good whatever discipline we are in. And I think one of the kind of people in AI call it the bitter lesson. One of the bitter lessons in advances in AI is that in the recent past, at least, it has seemed that as we just throw more and more compute at our AI systems, they are able to develop more and more of these abstractions. And right now, they're still clearly inferior to the abstractions that our brains have. But we can see the direction. We can see that they're becoming more abstract. They're becoming better able to develop little models of the world and to go in the direction that would be required to be essentially generally intelligent, to be able to do what we humans can do when we operate with our environment. And let me add perhaps one last thing to that. So Chris, you also brought up what I list here under point 7. It may be true that we prefer human service providers, even though the machines are better in every respect. And I mean every respect, including the emotional intelligence. So let's say an example that I sometimes hear when people want to argue about a job that will never be automated. Let's say you want to go to a psychotherapist. That therapist has a model of how human brains in general work. And as you speak to the therapist kind of refines that model and fine-tunes it to better fit your brain, to better understand what you are speaking about. And honestly, for the therapist, it's also not that hard to develop a model of the human mind because he or she can introspect and can kind of generalize from what they themselves are feeling to what other humans may be perceiving and feeling. A robot can't build on that introspection, so it probably has to be quite a bit smarter, if I can use that term loosely, a bit more intelligent than a human. But once it is, and once it develops a superior model of the human mind, it can also exhibit greater emotional intelligence, and it could be a better therapist.
I think we are more likely to destroy the planet through global warming than get to your state of AI. So we don't need to worry about it.
I am worried about that too, although I'm not sure about the timing.
Yeah. All right. Thank you very
Okay. So we have already touched upon a bunch of these points. I think we've covered 1, 2, 3 now. Sometimes people bring up comparative advantage, but I wanted to point out that comparative advantage just says that there are gains from trade. It doesn't say that if we trade with robots, we can earn a subsistence income based on our labor. So it may both be true that there are gains from trade between humans and robots, and that on a competitive market, we may not be able to earn a marginal product sufficient to cover our subsistence cost. And then a fifth point that I sometimes hear is, hey, we need humans to demand things in the economy. Otherwise, if there's no demand, the economy collapses. I've worked this out in another paper, and it turns out we actually really don't need human demand. We just could have an economy that is based entirely on investment demand. So let's say we have machines that are building better machines and better machines and better machines. And we know that output Y equals C plus I plus G. The consumption, the C could possibly go to 0 as long as I and potentially G is high enough. So it is perfectly possible that we have an economy in which there are ever smarter robots that build more and more and more factories for robots, and the economy grows and grows and grows, and there's no need for any human demand. Having said that, I, as a human, I hope that we humans will also get to consume some of the windfalls of such technological progress. But I'm just saying it's not necessary for us to consume, and unfortunately for us to exist. So I would argue that the first 5 points are objections that are either fallacies or based on presumptions that I disagree with. The last 2 are objections that I think are much more appropriate, and that may indeed kind of save us from economic redundancy if my premise that we have these machines with superhuman computing power will be developed is materialized. The first one is, well, if we have better and better machines, couldn't we also upgrade the humans to exhibit superior computing capabilities? I hear that Elon Musk is working on that with his company Neuralink, which is trying to kind of expand the human brain by giving it access to external compute. And that is perfectly reasonable from that perspective. So if we humans advance in our computing capabilities in a similar way to machines, then we won't be redundant. And then the second point, and that's something that we already alluded to in the discussion with Chris, is that if we have a strict preference for humans, even though the humans may not be as good as the machines, then there will still be demand for human services from that preference. I call it a preference for nostalgic jobs, because my premise is that humans will be surpassed in terms of the quality of the goods or services that they produce. But if there is that demand, then we can have a future of labor based on demand for nostalgic jobs. And that is also perfectly possible. Would anybody want to add comments here or ask follow-up questions? Okay, so for the next part of my presentation, I want to go into a normative exercise. And I want to ask, how do we allocate work and income to maximize utilitarian welfare as labor becomes redundant? And I will build this up from a very, very simple model to keep things very general. And I will start out with just a single individual whom we are asking how to allocate labor and consumption. And in fact, the model that I start out with is so simple that the first welfare theorem holds. So the individual's optimum is also the social optimum. So let's assume that there is this individual who values consumption and dislikes labor because there is a disutility of labor. For simplicity, let's make this utility function additively separable between the utility of consumption and the disutility of labor. And let me also add this subsistence level of consumption C0 that individuals need to obtain in order to experience non-minus infinity utility. So this individual has labor productivity, or if we interpret it as a competitive economy wage, W, if they are working full time. So if L equals to 1, or L approaches 1, then they would earn a wage of W. They also obtain non-labor income, T, and you can think of this non-labor income as either a transfer or also capital income based on the machines that they own. And the optimization problem of that individual, which is simultaneously the first best optimization problem of a planner who faces these parameters, is simply to choose how much to work so as to determine their total consumption WL plus T and the level of disutility from labor L. So what will that individual's optimization problem give rise to? Well, I thought, let's keep it intuitive, and I will first show it in a diagram and then briefly in a formal proposition. The first thing is there will be 3 regions for that individual. If the sum of the maximum possible wage plus transfer is less than the subsistence income, that means if we are below this minus 45-degree line here, then the individual will perish and will have utility of minus infinity. If the wage rises above this, or the non-labor income pushes us above this line, then the individual will work, and they will work first out of need and then out of choice when we are here in this upper region. And then there is a reservation productivity level W bar, which is a function of the non-labor income T, an increasing function of that, which delimits the work region from a third region, which is the region do not work. So if our non-labor income is high enough and our labor productivity W sufficiently low, then it is just optimal for this individual to not work, because essentially the first marginal unit of disutility from labor is less than their marginal productivity, and it's just not worth it for that individual to work, given that they have some other income. We can also look at this space and draw our ISO utility lines into it. So that's what I have done in the right quadrant. In this right quadrant, the utility, the ISO utility curves are at higher levels as we move to the right and upwards if we are here in region 2. And to just illustrate this, let's assume we start at some point A0, where the individual gets a certain level of non-labor income T and has a certain labor productivity. There are a bunch of possibilities that technological progress could give rise to in this setup. Let me start with the worst. The worst would be that the marginal product or labor productivity of the individual declines, but the non-labor income is unaffected. Then we would drop from this high utility, from this high ISO utility curve at A0 to a lower one at A1. It could also be that the labor productivity of the individual drops because of technological progress that's labor replacing, but our capital income, our non-labor income rises, and if it's just in the right proportions, we could stay on this ISO utility curve. Another possibility is that the marginal product, the labor productivity of the individual remains the same, but capital income goes up and we go to point A3 on a higher ISO utility curve. And finally, if we have progress that both raises the labor productivity and our non-labor income, that would be the best of all outcomes, and it could push us to this outermost ISO utility curve here in this illustration. That would be kind of similar to the neutral technological progress that we have seen in the past. whereas dropping down to A1 would be, I guess, the worst case scenario of labor saving progress without compensating transfers to the individuals who lose on earning opportunities. So if we want to capture this analytically, we can describe the three regions that we had in the graph as follows. There is the parish region if the non-labor and maximum labor income are less than subsistence. Otherwise, there is the work region, and we can describe the reservation productivity level of the individual as a function of the non-labor income that they receive, simply by looking at the ratio of the first marginal unit of disutility of labor, V prime of 1, and the marginal utility that they would receive if they earned only the non-labor income. And we can see that this reservation wage or reservation productivity level is increasing in the non-labor income that the individual obtains. So if we are in the work region, in the interior of it, labor supply is pinned down by our standard optimality condition, and we can find that an increase in non-labor income raises utility but decreases labor supply, and it also raises the reservation wage or reservation productivity level at which the individual decides to drop out of the labor force. An increase in the W in the wage or marginal part of labor, of course, increases utility, but has an ambiguous impact on L because there's an income or wealth effect and a substitution effect. And if the total non-labor income is less than the reservation utility, then we need to work a certain minimum amount. Otherwise, the individual would perish and would have minus negative utility. So the third region is if the transfer is greater than our subsistence level and the wage is less than the reservation productivity level W bar. And in that case, it is optimal for an individual to not work. It would be a waste of the utility of leisure if that individual was forced to stay in the labor force. So that's kind of the starting point of the analysis. The second point is how do we deal with this if there's not just a single worker, but if we have a continuum of workers, and let's say they differ in their labor productivity WI. And what I want to analyze is I want to analyze the optimization problem of a utilitarian social planner who decides how to allocate consumption and labor in order to maximize welfare, utilitarian welfare in this economy. So one question that I should also emphasize is how do we put together the labor of these individuals with different labor productivity? So I opted for a relatively simple way that you can see here at the bottom equation in the resource constraint. So I assumed that all these different individuals with different labor productivity WI will just be pooled together. So the overall amount of labor available to the economy is the weighted sum of labor provided by our individuals, weighted by the labor productivity of the different workers. So this is kind of a simple way to capture the notion that different individuals have different productivity, but that labor is otherwise a perfect substitute. So what will our planner do? I will follow the same recipe as before and first start with a graph and then show you the analytic proposition. So how do we allocate labor? Let's say I line up all the individuals of this economy on the horizontal axis in increasing labor productivity. And let's say the people under consideration in our economy, they are distributed between W min and W max. And my question is, how much should each of these individuals work? So one would be the maximum amount of labor supply. And yeah, how much labor would we allocate to them? Let me start in an economy that is kind of like the current economy we live in. It turns out our planner would find the optimal allocation to be given by a line like this one. So there is some reservation productivity level W bar, but all our individuals in this economy are above that level. And that means all the individuals are allocated to work. And interestingly, and it's kind of obvious and intuitive from the perspective of a first best utilitarian, the more productive individuals are allocated greater amounts of work because their overall contribution to production in the economy is more valuable. And so we want them to incur a little greater disutility of labor than the individuals with lower labor productivity. One way of putting it is the lower labor productivity individuals have comparative advantage in enjoying leisure from the perspective of the planner. So the planner makes them work less hard. Now, let's look at a comparative static. Let's say we have progress in this economy that increases output and reduces the marginal product of labor, of our composite of labor. What would the planner's new curve look like? Well, it would look like something like this. So you can see there is a significantly higher reservation productivity level now. And in fact, our planner would tell all the individuals with labor productivity below W2 bar to stay at home and not work, because even their first marginal utility, or their first marginal unit of disutility is not worth the amount of output that they are producing. So the planner says, well, it is desirable from a utilitarian perspective that you guys just enjoy your leisure, and the higher productivity agents, they are working and contributing to output, and they're doing more, so the more productive they are. Now, notice, this is, of course, very stylized because we are looking at the first best and not looking at things like incentives. But the interesting thing is, this is completely upside down compared to the world that we live in. In our world, and especially in poor countries and in countries that don't have a very developed welfare system, we make those with the lowest labor productivity work twice as hard so that they can make ends meet. And those with higher labor productivity can afford to work a little less. So from a utilitarian perspective, that's really such an inefficient system. Now, let's assume that we have further technological progress and that pushes out our optimal labor allocation line, so it starts at W bar 3. If this is the case, then the planner finds that the reservation utility level of individuals is actually greater than the most productive agent in this economy. And it becomes desirable to allocate zero labor to everybody. So this is literally the end of labor. And our planner says, everybody just enjoy your leisure and the machines can produce enough. We don't need human labor anymore. It would be a waste of work. You guys, you have much greater enjoyment if you just take your leisure and we distribute resources in another way. So this would be the end of labor. Now, analytically, for given levels of technology, meaning given overall output and given marginal product of labor, there is a reservation level of productivity W bar such that all agents less than that reservation level of productivity will be assigned zero labor in the utilitarian optimum. And the other individual will be assigned positive labor, and that is increasing in the amount of labor productivity that they have. If we do comparative statics with respect to the technology, it's also increasing in the marginal product of labor FL and decreasing in the overall output produced by the economy, because as agents get richer, they need to work less. The second point, everybody works as long as output is below a certain output level Y lower bar. The planner starts phasing out work once we surpass that output level, and all work is phased out once the, what I call autonomous output, it's different than the autonomous output in Keynesian models. The autonomous output here is the output that can be produced if only the machines work and no humans are involved. So once that autonomous output is above a threshold W bar 0, then all work is phased out and humans no longer work in the utilitarian optimum. Since it's a utilitarian optimum and we have separability between consumption and leisure, the distribution of consumption is independent of productivity. So that means everybody is just allocated the same fraction of total output, and that's what maximizes utilitarian welfare. Now, so far, we have discussed all of this under the standard assumption that labor creates this utility, but we haven't considered the role of amenities of labor that is, I think, increasingly important in our modern world. So let me expand our framework to account for work amenities, because especially as we engage in discussions about the end of labor, a lot of people argue that labor is not just exchanging your time for money, but there are also additional utility effects. So work amenities can include things like the identity or structure that our work provides us with, meaning that it gives us, the social connections that we all have when we go to work. For my framework, let's keep things simple, and let's say we can capture them in a single scalar, AI, that is essentially a constant alpha I times the amount of work that I engage in. And this can be a positive amenity or a negative amenity, depending on what we talk about. And let me also keep things simple on the utility side. Let's say we can just add the utility X from this amenity in a linear fashion to our previous utility function. Now, we know from the work that Rosen has already done decades ago that amenities can compensate us for wage income at some level. Let me define a compensating differential, not just for the amenities, but for work as a whole. And that compensating differential, which would be the amount of money that you need to pay me to make me equally happy as if I'm working and earning income, WILI, it can be greater than my wage income, can be less than my wage income, can be the same. It depends on whether these amenities are positive or negative and what level they are. The interesting thing is, for some workers, and maybe that includes Chris, work may be desirable even if the wage is 0. So even if our productivity and our competitive wage is 0 because we are basically redundant, people may still enjoy their work because of their amenities. On the other hand, if we look at surveys, about 2/3 of all workers in the US, and I think worldwide it's even worse, say that they are not engaged or disengaged from their work. So maybe for them, the compensating differential is significantly less than the actual work, the actual labor income that they derive. So if we extend our utilitarian planner's benchmark to the case of amenities, we find that there is a trade-off between our labor productivity and our amenities, and we don't have just a single productivity threshold, but we have a frontier of productivity levels and amenity levels that determines when we will phase out work. So I've illustrated this in the figure below. The figure shows our productivity on the vertical axis and the amenity level of labor on the horizontal axis. And if we are either very productive or we get a lot of positive amenities from labor, then it's desirable to work. Otherwise, if both the productivity and the amenities are low, and amenities could even be negative, then it is desirable for that individual to not work and just stay at home. So this so far is still an economy in which the first welfare theorem holds. So a planner and an individual who is allocated sufficient income would actually perfectly agree on these decisions whether to work or not. Now, the fourth case deals with something that makes it a little bit more complex. If you read policy proposals about how to deal with a world in which work may be phased out, you often see that they propose interventions to preserve work, but I find they don't usually spell out the rationale for that. So I think there is a risk of acting out of a certain status quo bias. And what I'm trying to add in the following slides is I'm trying to add a bit more of an economic perspective. So we economists, we believe that generally speaking, the invisible hand works at least to some extent, but we also believe it does not work if there are externalities or internalities, a term that people sometimes use for people not acting in their own best interest. So let's expand our model to account for these internalities and externalities. Let me start with externalities. What would be the potential externalities of work? One is something that we already mentioned, an amenity like social connections. And especially when we are not in COVID lockdown, we all very much appreciate that we can interact with our colleagues in person. So I think for us economists, social connections are, for part of our job, are definitely a positive amenity. Now, the thing about social connections is you can only enjoy them if somebody else is also working with you, right? Because otherwise it would not be social. And that's what makes it an externality. There are also potentially positive externalities from the political stability that work creates. So some political scientists argue that if everybody is working in an economy, if everybody is assigned their role in production, then the economy is more stable. There are also clear negative externalities, like if we all commute to work at the same time, then that commuting creates negative congestion externalities. Analytically, let's assume that we can capture all of these things again in a scalar that I call A bar, which essentially consists of a weighted sum of all the labor supplies of all the individuals in this economy, where each type J has contribution alpha bar J. So some people may be particularly social. They may have a very positive alpha bar J, even though maybe there are negative productivity spillovers, but let's not make it too complicated. Let's extend our utility function by this term that captures the public amenities. And then I just see there's a small typo down here. Let me also add the potential for internalities. So what would be an internality? An internality occurs when an individual is misperceiving the effects of their actions on their actual utility. So it's as if an individual maximizes a different utility function than the one that the individual really has. One way of capturing that in our framework is that the individual misperceives the amenities that they derive from work, and they perceive it as a hat deriving from a parameter alpha hat rather than the true amenities A or alpha. And you can just think of this second plus here as non-existent. So the utility function U0 that I've listed here would be the one that the individual maximizes, but the real utility function depends not on a hat, but on the true amenity value of work, which is A. What our individual would do now is no longer socially efficient, and a planner who decides how to allocate work and income would pick differently from the individual. So first of all, the planner now sets a three-dimensional frontier to decide when the individual should work or not. And that frontier depends not only on labor productivity and individual amenities, but also social amenities. And an individual who has sufficiently low values on all three, so who is not very productive, who doesn't get a lot of enjoyment out of work, and who doesn't trigger a lot of positive externalities, will be allocated no labor. An individual where any of those three is high enough will be allocated a positive amount of labor. Moreover, if there are these internalities, then a planner would find it optimal to impose a subsidy or tax on the individual to make them internalize their miscalculation. And in fact, the optimal subsidy or tax would reflect both the public amenity externality, that's the first term here, and then the misperception of the individual, the difference between the true amenity and the perceived alpha hat amenity. And of course, that's normalized by marginal utility. So that's the optimal subsidy that a planner would impose on individuals to make them act efficiently and to make them choose efficiently whether or not to decide in the labor market. So this concludes the second part of the analysis. The last part is much shorter and talks about how to basically prepare our institutions for the kind of world that we have been analyzing. So let me pause again for a moment and ask if there are any questions on the analytic part we just went through. Okay, so let me jump to the final part, to the question of our institutions and how we can adjust our institutions in a way that brings us a little bit closer to the first best that we have analyzed so far. The first thing I want to emphasize is that the main types of institutions that we currently have to allocate labor and income are the market and social insurance. And the interesting thing is, if both of them, if the market was really perfect, like in Arrow de Bro, then the market would also exhibit perfect insurance for all individuals. And for all individuals, even in an intergenerational setting. So let's say my long ancestors would have perfectly insured me against the risk of my labor becoming redundant in the market. And so in this kind of perfect free markets world with perfect insurance markets, we actually don't need any social insurance because the market has already produced precisely the first best that we have analyzed for the past half hour. Now, of course, we know in practice, we don't have perfect risk markets. One of the reasons is the same as why we don't have perfect social insurance, because they generate negative incentive effects. So it means in practice, what we have are free markets with largely missing insurance markets for long-term risks, such as the redundancy of labor. What that implies is large inefficiencies because of these missing risk markets and widespread miseries from those who don't have insurance, especially if labor were to become redundant. So we could not rule out that if labor really becomes redundant, that many individuals would fall into what we called the parish region in the beginning of our analysis. And that would, of course, really be undesirable from a perspective of utilitarian welfare. So our systems of social insurance substitutes for missing risk markets, but of course subject to the classic trade-off of efficiency versus redistribution. Now, one small point is the trade-off would actually be mitigated if labor becomes redundant, because we won't have negative incentive effects on labor anymore as soon as there is no social role anymore for labor. So there are many different kinds of transfers. Let me, in the interest of time, jump kind of to the most important one. One important solution that a lot of people have advocated if labor becomes redundant is a universal basic income. A universal basic income distributes income in a non-distortionary way. As long as there is some labor still in the market, it would have a negative impact on labor supply due to income effects, but that's perfectly desirable. It just says people decide not to work as hard if they don't need to, kind of in the similar way that Chris observed earlier that Keynes would have predicted. Now, the downside is a UBI requires large amounts of revenue, and of course revenue implies if we raise that, we will impose costly distortions from taxation. Should also say a universal basic income, at least as long as there is still a role for labor, is far from implementing the first best allocation, especially if we account for incentive constraints. And I should emphasize that replacing the current system in the situation we live here and now with the UBI would definitely hurt the most needy. Because right now we have a social insurance system in most advanced countries and also a lot of emerging economies that is very targeted at those who need it. A UBI that replaces the current system would take away that targeting and would make a lot of people worse off. So in the present system, replacing social insurance with a UBI would be definitely undesirable. However, if labor is really phased out, it may be our best choice. And what we propose in the paper, in fact, is we propose to prepare for a future in which work may become redundant by introducing a small UBI now. And that UBI should be set such that it automatically rises as the share of labor and income declines. And the second proposal that we make to better prepare us for such a world is we really need to separate the provision of social insurance from work, because right now many countries, including the US, have social insurance systems that really force people to work. For example, the earned income tax credit in the US. And that would be really desirable if work becomes less and less socially valuable. So I believe we are at time now. Let me quickly emphasize that we don't want to subsidize work unless we believe that there are really important externalities coming from work. And I will just conclude here. This paper has argued that labor may soon cease to be the most important factor of production in the economy. And as a result, the allocation of income really needs to be separated from work. There is a risk of widespread misery if we don't, but a potential for very large welfare gains if we do. The institutions to provide social insurance in such a future are urgently needed, and building institutions takes time. So if anything like the timelines of Elon Musk and Ray Kurzweil are correct, then we really have to urgently work on developing these institutions now. And then final point, the non-material amenities of work will play a growing role in the future as the productive aspects of work are becoming less and less important. Thank you very much.
Maya, can I ask you a question?
Please.
Yeah, I think your argument is very interesting, but I think one missing thing right now, I think, is so as the society develops, technology develops to the level that productivity of the machine develops so much, so nobody has to work. Yeah, let's assume that is the case. So then I think we have to talk about who actually owns all the machines. So for example, and also we have to talk about what kind of machines we are imagining. So for example, let's imagine that the machines we're going to develop is like a humanoids. So we're going to have all the humanoids whose productivity is like much higher than us. And in that case, if we actually just imagine that everybody has their own replica of their humanoids, and humanoids gonna work for you or for me, and then we actually do not need a universal basic income, because we just substitute our labor. We just like delegate our labor to our replica, right? So I think that kind of the debate on who owns the machine and what kind of machines we are talking about is actually quite important.
Two quick reactions. First, you are absolutely right. The question of ownership of these machines is a really critical one. So in the paper, I haven't touched upon how exactly these transfers T come about, but I am discussing that it could be either a pure transfer, or it could also be from sufficiently distributed ownership. So those are both feasible ways of distributing that revenue T. And there are probably good political economy reasons why it may be desirable to have distributed ownership of the machines. We have to also make sure that people can't, suddenly sell their machines. Let's say they have a gambling addiction. They sell their last robot so that they can gamble, and then they're left with nothing. That would be extremely undesirable from a utilitarian perspective, right? So there is probably a case of having a basic transfer that is independent of machine ownership. But I very much agree with you that distributed machine ownership, and especially if you cannot sell all of your machines, could solve the distribution problem. I think there is lots of papers to be written about the ownership of factors of production in such a world. Right now, we kind of take it as given that everybody has their labor to fall back upon. Even if we declare bankruptcy, most of us, at least those of us who are not disabled, can still work. But if work is no longer valuable, then that will no longer be true.
Okay, yeah, it's actually a really interesting topic. Yeah, I haven't thought about it. But okay, yeah, thank you.
Thank you. Thank you for all the interesting comments.
Yeah.
Thank you. Bye-bye.
Thank you.
All right. Bye.
Yeah. Any other questions?
No, I have to go.
If I may, sorry.
Please.
Oh, okay. Hello. It's really a fascinating lecture slide, and I'm not sure I'm missing the first little bit half. Sorry, but
No
I have
problem.
one quick question regarding your conclusions on allocation of income needs to be separate from work. I'm not sure, are you familiar with the equity of opportunity from John Romer? from University of Yale University, the equity of opportunity, or inequity or inequality of opportunity. IOP.
Inequality of opportunity. Yeah, I guess one way of thinking about the world that I have described is that ultimately, if labor is perfectly redundant, then our opportunities to earn labor income, they're perfectly equalized, right? Because we are all redundant. But during the transition,
yes,
inequality may be exacerbated. And then going back to Sang-Woo's observation, inequality in ownership of factors of production.
Yes and no. Like one of his main argument was that the allocation of income should not be determined by circumstances that are not that beyond one's controls, like races, genders, parents' educations, etc. And the income distribution should be more ethically acceptable by efforts, which mainly determined by the hours of work or education that you received. That's a more ethical, acceptable ways to allocate income, at least in his perspective, and it's somewhat popular in the scholars. However, if the allocation of income separate from work, then it's impossible to determine the individual's effort level in that perspective. I'm just wondering, I'm just really curious. Would you like to comment on that,
I think it's a really interesting observation to bring this up here, because it just shows how our world is so organized around work. It's so wedded to the concept of work. Even a lot of our ethical frameworks put work kind of at the center stage. So if my concern that work becomes redundant materializes, all that is going to have to change. And I think, so I agree with the fairness notion that if our, let's keep it in the economic realm, if our consumption, our utility is determined by random factors out of our control, and some people inherit a lot of machines, other people inherit very few machines, that seems unfair, right?
Yes, yes.
And it would argue that it is more ethically desirable to make sure that the distribution of factors of production is not too unequal. But at the same time, the framework can no longer put labor and effort, the effort involved in supplying labor at the center, because labor will be fully redundant in this kind of world.
Yes, I understand. Then is there alternative in that circumstance? Under this circumstance, is there alternative ways? Because the way I see UBI, it's more like a algorithm, like how provides everybody with equal amount of income. For instance, like a Gini coefficient equal to approximately 0, which may not be a desirable distribution of income, because some, like argued by Romer, some made more effort than the others. I'm just a little curious on how alternative other than UBI will be served, since labor will be redundant, a more ethical, acceptable way to distribute income, because as many of our income is the main source for us to live better, at least for now. So
for me too.
Yeah, so some that works harder and others may work less harder. If work is no longer needed, then how do we ethically separate the more effort individuals and the less I'm just really curious from this perspective.
I can tell you only two thoughts that are related, but it's of course a much bigger problem that I can solve. The first thought is the transition to a world without labor won't happen all at once, and people will carry their unequal levels of ownership of assets and factors of production into that new world. So because of that, even if we were to distribute a perfectly equal UBI at some point, there will still be inequality based on past ownership claims. The second thing is, it seems that people have a very strong urge for a strong yearning for status goods and for rankings. And I'm not quite sure how to think about it in the context of a world where people can't compete in the labor market anymore, and people can't compete in who accumulates more assets, who accumulates the greater houses, the bigger cars, and so on and so forth. It will really be a very different world, and I hope we will find ways of managing things more ethically than we do in today's world.
Yes, I agree. One last, just it will be like, if it's the words that you're picturing in the first scenario, in my understanding is that much lesser social mobility, and that's just not really good. That's it. That's just one last sentence. Thank you.
Yeah, I see.
Yeah, I think we way past the time, so I think we can wrap up here. And I thank you very much, speaker, for the wonderful and interesting, provoking thought. Yeah, actually. Yeah, and thanks to the audience for participation. Yeah, thank you.
Thank you again, and I hope everybody will contribute to preparing our societies for a potential future of labor no longer existing.
Okay.
Goodbye.
Yeah.